Welcome students. Today we're going to be solving systems of equations using concrete models. And our concrete models that we're going to be using today are algebra tiles. We haven't done a ton with algebra tiles this year, but we want to show you and let you see them and have a little bit of experience with them, because you could see a question on your EOC or on your checkpoints this year that involve algebra tiles. The one thing you need to know about them is that you don't really have to use them to be able to solve the problem. The main reason we're doing this lesson today is so that when you see a problem that does use algebra tiles, you're not like, oh, I've never seen these before, I don't know what to do, I'm just going to skip this problem. So just know that even though we solve these with algebra tiles today, when we get to our checkpoint and you see algebra tiles on there, you could use any of the other methods. You could solve them for y and put them in the calculator. You could use elimination, or you could use substitution. Okay, so we just want to show it to you so that you're not completely caught off guard by them. So with algebra tiles, the long blocks are x's. Okay, if we color it in, this is usually red when we're dealing with an algebra tile. That's a negative x. Ones are the little squares, and negative ones would be the colored in or red squares. Okay, so to represent a problem or an expression 2x minus 3, we're going to have 2 of the x rectangles and 3 of the minus 1s. Okay, so when we go down and start looking at these, example 1 here, you have 1x, 2x, 3x, 4x, so this is 4x plus a single 1. In the second one here, you have 1x, and then you have a negative 1, negative 1, negative 1, negative 1, negative 1, which is 1, 2, 3, 4, 5, negative 5. Here, this is a negative x, negative x, negative x, so that's 1, 2, 3, negative 3x's, and then plus 1 makes plus 2. Okay, pretty easy just to get the idea of how to use an algebra tile. Okay, now we're supposed to illustrate an equation, so we have an equals in there, so we know that, and we can say that this is 1x, 2x, 3x, plus 1 is plus 2, and this is negative 1, negative 1, negative 1, negative 1, or negative 1, 2, 3, 4, negative 4. On this side, we have our equals for number 5. We have 1x, 2x. We have 1 minus 1. And then on this side, we have plus 1, plus 2, plus 3. So 2x minus 1 plus 3 equals 3. Now here, we're supposed to illustrate it, so I have 2 of the negative x's colored in. And then I have 3 of the singles. That equals 1 of the colored in guys. 1, 2 x's. They're negative because they're colored in. 1, 2, 3 regulars. And then 1 negative 1. Okay, there's 3 x's. 1, 2, 3 x's. A negative 1 colored in. And equals. And then I need 5 small boxes on the side. So 3x minus 1 equals 5. Alright, now we're going to use the method of substitution to be doing this. So right here we see that y equals 2x. So right here y equals 2x for the boxes. So what we're going to do is we're going to take that and we're going to insert it in for the y right there, just like we did in class when we did substitution, but we're going to be doing it looking at the tiles. So here, negative x is just a colored in that. Y is being substituted in for these 2 x's. So plus 2 x's equals 4 singles. Okay, and that's just what we're not actually solving this one yet. I'm just showing you what it looks like to substitute it in. All right. Now, as we get further into these problems, we're going to need to learn how to represent a solution. So we get down to the end and we see that we have 2 x's on this side, and then we have 1, 2, 3, 4 singles on the other side. And so what we do is we do grouping. And so we have 2 groups of 2 over here, so we're going to split these into 2 groups over here. And so what this tells us is that 1x equals 2. So for every x on the left, we have 2 boxes that would go with it on the right. So it'd be like if you were dividing up teams, and this is the captain on this side, and these are the players over here. This captain is going to get 2 players on his team because x equals 2. And when we look at number 10, Do the same thing. We have 2 on this side, so we got to divide these up into 2 groups. It makes most sense to draw my circle this way, and so we find out that 1x equals -1, -2, -3. On this one we have 1, 2, 3, so we're going to split this up into thirds, and we have to split this up into thirds also. So there would be 1, 2, 3. That would be our thirds. 1, 2, 3. So 1x goes with 1, 2, 3, 4 singles. If the x's are negative, we have to flip every box on the other side to find the solution. So we flip these to be singles, and we're going to flip these. And when we flip them, they're no longer clear boxes, they're colored in boxes, which makes them all negatives. And that's really what happens when you change signs anyway. So now I divide this up. There's 1 single equals, or 1x equals 4 of these -1s. So x equals -4. And that's what you do when you get down to the very end and you're trying to figure out the solution to one of the problems. Alright, so here's a whole problem that we're going to work through. We know that x plus 1 is equal to y. Okay, so what we're going to do is we're going to take this problem, 3x plus y equals 9, and we're going to model it with algebra tiles. So I got to do 3x's on this side, and then I know that y is equal to x plus a 1. And then over here I have 9 singles. One, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So over here I'm going to group together my x's. So I have 1, 2, 3, 4 x's. Here, I want to get rid of this x, but whatever I do to this side, I got to do to this side as well. So now I'm down to just 8 singles over here. Okay, now I'm ready to figure out my answer, so I'm going to split this up into 1, 2, 3, 4 groups. So I have to split this up into 4 groups as well. 1, 2, 3, 4, and what I find out that 1x equals 2 singles. So x equals 2. Once I find out that x equals 2, I'm going to take that and plug it right back into here. Y equals x plus 1. I'm going to take out x, put in 2, and I find out that y is equal to 3, and so there is my answer, 2, 3. Okay, we'll spend a little bit more time in class on doing these tiles so that you're comfortable with them, but ultimately know that we could do this by solving each of these for y and plug them into our calculator just like we did last week and get the answer probably faster than drawing all these boxes. We just don't want you to be scared off when you see the boxes.